Math 242, Cuesta College. I'm Joe Vasta, and we are covering 9.4, which is the binomial theorem. The binomial theorem, we're going to try to make this as simple as possible. It can get more complicated. We're going to start off with a binomial. What is a binomial? A binomial is, we'll call it a polynomial with two terms. So this right here, x plus y, that's a binomial. Well, the binomial theorem gives a shortcut. So this theorem is a shortcut to take binomials to powers. So I'm going to go ahead and take this binomial to different powers. I'm going to take it to the 0th power first. And this is kind of dumb because if you take it to the 0th power, things to the 0 power happen to be 1. Let's go ahead and take x plus y to the 1st power. Now when I do that, I get x plus y, but for some reason, and this is not how we want to keep our answers when we're doing problems in our homework or on the test, but I am going to do it this time. I'm going to write this as 1x plus 1y. Okay. Usually this is discouraged, putting the 1 there, but I'm going to do that this time. I'm going to go ahead and go x plus y squared, or to the 2nd power. And so it's x plus y times x plus y, which is a FOIL. And when you're done foiling, you end up getting 1x squared plus 2xy plus 1y squared. Okay, so the next one that I want to do is x plus y to the 3rd. Okay, x plus y to the 3rd. I'll go ahead and do that up here. That's x plus y times x plus y times x plus y. So this is not fun to do. I mean, these guys here will give me what I have here. So this will be x squared plus 2xy. Not writing the ones on this one here. And then I'm going to multiply that by x plus y. So now I can't just FOIL. I have to do 6 handshakes. Everybody over here shakes hands with everybody over there. So I have x squared times x, which is x cubed. X squared times y, which is x squared y. And then now the 2xy is going to shake hands with those guys. So this is going to be plus 2x squared y plus 2xy squared. Now y squared is going to shake hands with those two guys, so we have plus xy squared, keeping things alphabetical as I'm multiplying, plus y cubed. So now collecting like terms, you only have 1x cubed plus, how many x squareds do we have? We have, x squared y's. So I'll underline that 3 times, and we have that guy right there, and what else? Oh, this guy is right next to him. We have 3 of them. 3x squared y plus, and then these guys, xy squareds, we have 3 of those. Plus, and then the last one is a 1y cubed. Okay, so notice there's a few things that are happening here, because the next one that we want to do is x plus y to the 4th. And I know what you're thinking. You're thinking, no way, we can't do that. Well, we can. And the first thing to realize is that, look at this last one. This character here, he's an x, and he's fully alive. He's to the 3rd power. And what happens as I go to the next term? He's dying off. X squared, x to the 1, and now he's dead. X to the 0. Now, y, who's the 2nd character in this play or whatever, he's dead. Y to the 0, y to the 1, y to the 2, y to the 3. That's exactly what's going to happen here. You're going to have an x to the 4th plus. Now there's going to be some coefficients, the 1, 3, and etc. X cubed, and then we have, keep it spread out here a little, we have x squared, we have x to the 1, so I'll just go x. And then the last one, which, you know, you could put if you want, it's really x to the 0. Now over here we have a y to the 0, and then over here we have y, and y becomes alive. Look, I'm increasing his power. Okay, but that does not solve the problem of where do I get the coefficients. So now we're going to talk about the coefficients. Some of you may have seen this before, but maybe you haven't. There is something famous called Pascal's triangle. Pascal's triangle starts with 3 1s right at the top, and then the next row is going to be 1, and there's always going to be 1s on the outsides. So this next row is going to be 1, and then you add the 2 numbers right above. So 1 plus 1 is 2. That's how I get that row. So the next row will be 1. Always start with a 1, and then you say, what is this? 1 plus 2 is 3. 2 plus 1 is 3. And then we put a 1 there. Does that look familiar? 1, 3, 3, 1. Look. 1, 3, 3, 1. It's these numbers right here. And you could even say, well, look at this. Here's 1, 2, 1. 1, 2, 1. And you have the 1 1s here. 1, 1. And last but not least, you have this guy right here, which is just a 1. So how we're going to find these coefficients here is we are going to go ahead and generate the next row of Pascal's triangle, which starts with a 1, and then we go 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and then we have a 1 there. So it looks like we have a 1, and we just copy this right down. 4, 6, 4, 1. And that's how we got x plus y to the 4th. So that is the deal with Pascal's triangle. Pascal's triangle can be used to do powers of binomials. Now we'll try to get a cleaner way of doing this, and we'll tell you a few more things about Pascal's triangle when we hit the next problem. So Pascal's triangle gives you the coefficients, and then you got to remember the powers, you know, where 1 dies off and 1 comes to life. So I think we should do some problems now and see how we do with these problems. Oh, maybe I should say this right here. This guy right here, this row, is called row 4. Now you might think that that's kind of a contradiction because, you know, here's the first row. The first row is just a 1, and then 2, and then 3, and then 4, and it really is the 5th row, but we call it row 4 because the second entry is a 4, which means this guy right here, this row here, is row 3. This row right here is row 2. This is row 1, and then up here we have row 0. Okay, and that's just the way they number it. It's actually easier to find things on Pascal's triangle if you use that numbering. Let's go ahead and do some problems now. So you get stuff like this in your homework. Expand this. Okay, expand. What we're going to do is, we see it's to the 4th power, so we're going to go to row 4 on Pascal's triangle. So I'm going to go ahead and write out Pascal's triangle here. It's the same thing I wrote on the other page, and I'm going to row 4, which is that one right there. Okay, so I'm going to show you how to do this in a different kind of format. So hopefully you're all right with this format that I'm going to show you. I'm going to start off by writing these numbers 1, 4, 6, 4, 1. Notice that when I did it this way, there was like awkward spaces at the end, and I don't like that. So what I'm going to do to solve that problem is I'm going to write these guys out like this. 1, 4, 6, 4, 1. I'm going to write out that row in a vertical fashion. And now I'm going to go over to this first character here. He's an x squared. And one thing we know about x squared is he's fully alive. And when you're fully alive, you're to the 4th power in this example here. And what happens to x squared? Well, look, he's dying. You know, he might even be saying, help, I'm dying. And he is dying off until he becomes what? Until he becomes x squared to the 0. Now, do you really have to write that? Because anything to the 0 power is 1. We don't really have to write that. Okay, now, who's the other character? Now, you might say 2, but it's actually negative 2. So negative 2 is fully dead. Then, negative 2 comes to life. So look, that becomes a 1, and then a 2, and then a 3, and then a 4. Okay, so now let's go ahead and multiply those out. On the first thing, we have a 1 times x squared to the 4th, and times a 1. That red thing's just a 1, so this is an x to the 8th. Okay, let's multiply this out. We have, this is really going to be an x to the 6th, and then we have a negative 2 times a 4, so this is negative 8x to the 6th. Now I have a negative 2 times a negative 2, which is a positive 4 times a 6. So that's a 24. X to the 2 times 2, 4. Okay, this is negative 2 times negative 2 times negative 2, which is negative 8 times 4, which is negative 32. X. That's going to multiply those, so you get x squared. The last one, this red thing, is just a 1 there, and you have negative 2 to the 4th, which is 16. Now, I didn't want to rewrite those like that, but this is our first problem, so I wanted to do that just, you know, just to kind of slow it down a little. Our final answer is going to be this right here. We're going to add those 5 terms. X to the 8th minus 8x to the 6th plus 24 x to the 4th minus 32x squared plus 16. Do you notice anything about these terms? What's happening here with the signs? The signs are alternating. That will always happen when you have a negative there. Now when you have a positive there, then they're all going to be positive. So sometimes when people do this step, they don't put the negative there. They'll just remember the first one's positive and they'll just alternate the signs. Okay, so that is the answer. This is the shortcut. You know, on the next one there's going to be a 5 there, and this is really, it does save a lot of time using Pascal's triangle to do this. Let's go ahead and do problem number 2, which has a 5 there. Okay, so this means I've got to go to row 5 in Pascal's triangle. So I'm drawing out Pascal's triangle again. It's an important thing to know in a math class, Pascal's triangle, because it comes up from time to time. So row 5 is going to be 1. 1 plus 4 is 5. 4 plus 6 is 10. Notice with Pascal's triangle you have symmetry. Once you get halfway through a row, the other half is just repeating what you did over there. So let's go ahead and put our numbers here. 1, 5. This is row 5 because it has a 5 there. 10, 10, 5, 1. Okay, so our first character is X, and X is fully alive, and he is dying off. And x to the 0, which is just 1. Now this guy right here, you know what? I'm going to rewrite this person. You could do it like this, but I'm going to go ahead, and I feel a little different about this. I'm going to go negative 1 over x, because that's what x to the negative 1 is. It's 1 over x, and you have the negative in front. So that guy is dead at the beginning. That says negative 1 over x, and then what happens? Then you have negative 1 over x to the 1, negative 1 over x to the 2, negative 1 over x to the 3, negative 1 over x to the 4, and negative 1 over x to the 5. Okay, so let's go ahead and see if we can write something out here. The first one is going to be x to the 5th. The next one is going to be 5, x to the 4th over just an x. The next one's going to be 10 x to the 3rd over x squared. Okay, and I am blowing it because I forgot that negative there, so I had to put the negative in front. Remember, when there's a negative there, these are going to alternate. So this one's a negative, positive, because negative 1 squared. So this one's going to be 10 x squared over x cubed, and there is a negative 1 cubed, so I have that. This one right here is going to be 5x, because that's x there, over x to the 4th, and then the negative is to the 4th, so it's positive. And then this one's going to be negative 1 over x to the 5th. So when we write these out as 6 terms, we have x to the 5th, and then this one's going to actually be minus 5x to the 3rd. The next one is going to be plus 10x, and then minus 10 over x, because we have an x squared over x cubed. And then we have plus 5, this part becomes over x cubed. And then the last one's negative 1 over x to the 5th. So using Pascal's triangle to expand out a power of a binomial really is a shortcut. We don't really want to write that out 5 times and do that, because there's more room for error when that happens. Let's go ahead and do the next problem. The next problem is this. So then in your homework they'll have some that say this. Hey, find the term containing x to the 6th in this expression here. Wow, so that's crazy. So that is what we're going to do. Looks like I have to go to row 6 on Pascal's triangle. So that's what I'm going to do now. 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Okay, so new row, row 6. 1, 6, 15, 20, 15, 6, 1. So I'm going to write this like this. So the other weird thing about this is you're just finding the term containing x to the 6th. You don't have to write all of that out. And that might save you some time. So 1, 6, 15, 20, 15, 6, 1. Okay, first term is 3x squared, fully powered up to the 6th power. Okay, and then this is 3x squared to the 5th, 3x squared to the 4th, 3x squared to the 3rd, 3x squared to the 2nd, 3x squared to the 1st. Meanwhile, this guy is negative root x. Okay, so negative root x to the 0, negative root x to the 1, negative root x to the 2, negative root x to the 3, negative root x to the 4, negative root x to the 5. And if you've done enough of these, you might not have to write all these out to find the term containing x to the 6th. Okay, the term containing x to the 6th. Well, first of all, this right here, when you multiply it out, it's going to be x to the 10th times root x, which is not an x to the 6th. So we can, like, say, we can rule out the first one and this one and any one where the square root is to an odd power, because it's not going to give us a nice answer. Okay, this one says x to the, you multiply those, so this is x to the 8th times another x there. And there's a negative there, so this is going to be x to the 9th. That is not what we want. This one's going to give us x to the 4th. And then the square root of x raised to the 4th power is going to be an x squared. So we thinking maybe this is going to be the 1, and this one definitely is going to give us an x to the 3rd, which is not what we want. So this is, so we can determine that that is what we want there. We want this term, and that's all they're asking for in this. So let's write things out here. We have 15. 3x squared squared. So this is going to be times 3 squared is 9, x squared squared is x to the 4th. And then this, that negative is going to go away because there's a 4th power. And you're going to have really square root of x to the 4th. Now the square root of x, there's a few ways of doing this. One of the ways is saying it is x to the 1/2 to the 4th. Another way is just writing out 4 of those and then seeing that, you know, root x times root x is x, root x times root x is x, and then you get the same thing we get here, which would be x squared. So this thing gives me 15 times 9, I think that is 135. We have x to the 4th, and then we have x squared. So find the term containing the x to the 6th. It's going to be 135 x to the 6th power. So this really completes everything. This is our very last lecture. We'll have a review video, but we've finished all the new material. This right here is a bonus. Right now, some of you might want to turn off the video. This was Pascal's triangle. Well, it just so happens that these numbers that in Pascal's triangle, they're called combinations. And these combinations are written kind of funny. So, you know, 3 equals this thing that says 3, 1, and then 3 equals 3, 2. This is called 3 choose 2. Some of you may have seen this in statistics. So this guy, let's just focus on 5 choose 2. 5 choose 2 happens to be 5 factorial over 2 factorial times 3 factorial. Now, this is just a definition. You don't need this to do your homework. So this is really 5, 4, 3, 2, 1, and then you have 3 factorial is 3, 2, 1, and then 2 factorial is 2 times 1. Well, the 3's cancel, the 2's cancel, the 4, so you end up getting 10. Okay, so we see 5 choose 2 is 10. Now in statistics you might have to do these combinations. So Pascal's triangle is made up of combinations. So when your book, and maybe other books do this, they say, oh, let's look at the binomial theorem. They scare people by writing the theorem in summation notation. So they'll say x plus y to the 5th, this equals, and then they'll go summation I equals 0 to 5, and they'll go 5 choose I, x to the 5 minus I, y to the I power. And they'll say there's the binomial theorem for x plus y to the 5th. And if you wrote out I equals 0, I equals 1, and wrote that out, you would actually get what we've been talking about in the other problems, where x is fully alive and then dies off, and y is fully dead and comes to life. And to make matters worse, your book was probably going to go x plus y to the, and replace the 5 with an n. And then that would be an n, and that would be an n, and then there would be n minus I up there. And it can get a little more confusing with the notation. So if you go to read your book, just know you've been warned. Maybe you just want to use this lecture, do things using Pascal's triangle. I've skipped the combination stuff in the homework because we just don't need that. And this is our last lecture in terms of new material. So study hard, get caught up with your homework, have a good day.